Welcome to the series of videos where we solve the questions in the 2026 WASSCE Core Maths Paper 2. In this series, we solve the second part of the questions in Paper 2. We already solved questions 1 to 7, and over here we solve the remaining questions, that is questions 8 to 13. As usual, the full set of questions and solutions may be found on our website, preppyonline.org. Question 8. 3 towns, A on latitude K degrees south, 20 degrees west, B on latitude K degrees south, longitude 0 degrees, and C on latitude 15 degrees north and longitude 0 degrees are on the surface of the Earth. The shortest distance between B and C is 2,560 kilometers. A. Illustrate the given information or illustrate the information in a diagram. B. Find, correct to the nearest degree, the value of K. II. Find, correct to 1 decimal place, the shortest distance from A to B. Find, correct to the nearest hour, the time taken for an aeroplane to fly from B to C at 800 kilometers per hour. So we start from A, where we want to illustrate the information in the diagram. We go to a fresh page so that we can get enough space to do the illustration. So this question invites us to think of the Earth as a sphere. So you can think of a huge ball with a center. We can call the center O. That's not so important. What's important right now is for us to find the longitudes that I mentioned. So this top is the North Pole, and then the bottom here is the South Pole. So we can draw something like this for longitude 20 degrees west, and then we can draw something like this for longitude 0 degrees. So this is 0 degrees, and this is 20. Let me write it this way, 20 degrees west. All right. And then we also have to draw our latitude. So let's draw this latitude as K degrees south. So K degrees south. And then let's draw this one as 15 degrees north. 15 degrees north. All right, so we are told that A is at the intersection of K degrees south and 20 degrees west. So this is going to be our point A. And then our point B is going to be K degrees south intersecting with 0 degrees, which is also called the prime meridian. Meridian at 0 degrees, longitude 0 degrees is called the prime meridian. And then we have point C, which is 15 degrees north and on longitude 0 degrees. So this is going to be our C. So we have C, we have B, we have A, and we are told that this distance, the shortest distance, which is the distance along the surface of the Earth between B and C, is 2,560 km. So this distance, let me use a different color. This distance is that 2,560. All right, so this qualifies as an illustration of the information given. We have our point A. Of course, we are not writing the coordinates because those are given in the question, and it's implied because if A is on K degrees south, this is K degrees south, and 20 degrees west, this is 20 degrees west. So the intersection of those two is going to be A. Similarly for B, and then for C. So this is our illustration of the information. Question 8bi. So we repeat the question just for easy reference. We are asked to find to the nearest degree the value of K. So here we draw the sphere again. So we are thinking of the Earth as a sphere, just as we did it's convenient to label the center. So let's call this our latitude just like we did, k degrees south, k degrees south. Then we have our latitude here, 15 degrees north. Then we have our two longitudes, have our North Pole, South Pole. All longitudes must begin at the North Pole and end at the South Pole. So when you draw them, then you know that you're trying to connect them. And then we have our point A here. This is longitude 20 degrees west. And then this is longitude 0 degrees. And then we have B here. B is at the intersection of the prime meridian, which is longitude 0 degrees and k degrees south. And then C is here. So this is C, this is B. And we are trying to find to the nearest degree the value of k. Remember that we are told, so this, let's draw an imaginary line for the equator. So the equator is the latitude that divides the earth into two from top to bottom. So if we have our equator like this, then a line from the center to where the equator meets the prime meridian, for instance, that line, if we now depress or we go down from that line k degrees, that is what B being on latitude k degrees south means. It means that this angle is k degrees. So it's a bit, maybe if you're not familiar with it, it may take some getting used to. But the idea is that you're standing on the plane that is at the center of the earth. And then you look down k degrees south, and that's going to take you to the latitude on which we have A and B. So this latitude is also a plane. You can think of it as a plane. All right. So now, if we have this, we can draw a similar one from the center, call the center O. So we've drawn a line from the center O to C. We've drawn another one from O to B. So just as the one from O to B had to be depressed by k degrees, the one from O to C has to be elevated by 15 degrees. Remember, C is also on latitude 15 degrees, which is also a plane. So we can draw a circle. Let me just extract this information. So this point where the line from the center meets the longitude 0 degrees, let's call that point E. All right, so let me draw a circle, a small circle, just so that we understand it better. So this is the center of the earth, and then we have these points. So this is point E. Then you go up 15 degrees. 15 degrees, you have point C. And then you go down k degrees. Let me use a different color. So we have k degrees here. And then when you go down k degrees, you have point B. All right. And this distance is the radius of the earth. This is point O. And we are trying to find to the nearest degree the value of k. Now remember that we've been given this distance. So the distance from B to C, we are told that this, or the shortest distance, that just means the distance along the curvature of the earth. The distance from B to C, we are told, is 2,560 kilometers. But from our diagram, this distance is simply the length of the arc. And we can find the length of the arc if we know the angle that it subtends at the center of the circle. And the angle that it subtends at the center of the circle is this angle, which is 15 degrees. Let me write 15 plus k. So this 15 plus k over the total angle at the center of the circle is 360. We multiply that by 2 pi r. Here, big R is the radius of the Earth. So this is going to give us 2,560 kilometers. And so from here, we can do some substitutions. We substitute a value for pi and a value for r. So we get 15 plus k over 360 times 2 times pi, which is 22 over 7, times r, which is 6,400, is equal to 2,560. So we are trying to simplify it, and we are trying to solve for k. So we just have to get rid of, for instance, this fraction on this side. And the way to do that is just to multiply by the reciprocal. So we can write 15 plus k over 360 is equal to 2,560. Now we have to multiply by half if we want to get rid of the 2. So we want to get rid of this 2, so we multiply both sides by half. If we want to get rid of this 22 over 7, we multiply both sides by 7 over 22. If we want to get rid of the 6,400, we multiply both sides by the reciprocal of 6,400. That's equivalent to dividing by that or multiplying by 1 over 6,400. So we try to cancel. At this point, you can just punch this into your calculator to get the answer right away. But it's always good to try to cancel. We can use 128 to cancel. When we do that, so first, if we cancel the zeros here, we are left with 256, which we cancel with 128 to get 2. If we cancel this with 128, we get 5. This 2 cancels this 2. So we are left with 7 over 22 times 5. So we now have 15 plus k over 360 equals 7 over 22 times 5 is 110. All right, so let's try to see if we can use the space. So we multiply both sides by 360. We have 15 plus k equals 7 over 110 times 360. So again, we cancel the zeros. We have 7 times 36 over 11. And what is 7 times 36? 36 times 7, 7, 6, 42. So we have 4. Then we have 252. So this is equal to 252 over 11. So our k is equal to this 252 over 11 minus 15. Again, we can punch into our calculator to see what we get. That's going to give us the answer right away, but we can always try to do it by hand. And one way to do that is to try to divide this 252 by 11. What do we get when we do that? Well, 11 divides 25, we get 2, remainder 3, so 32 divided by that is another 2, remainder 10. So we have 22 whole number, 10 over 11 minus 15. And this is equal to 7 whole number, 10 over 11. So that's the value of k. K is equal to 7 10/11ths, or 7 whole number, 10 over 11. But we are asked to find to the nearest degree. So we want to round this to the nearest whole number, and that is 8. So this k degrees that we saw here is actually 8 degrees. Same as the k degrees we have here. It's actually 8 degrees. All right. So same question 8. We are now doing BII. We are supposed to find to one decimal place the shortest distance from A to B. So again, we have our sketch of the Earth. big ball. And then we have our latitude, K. I'm drawing this over and over again so that we get some familiarity with drawing the Earth as a sphere. All right, so we draw our equator. That's in the middle. We can draw something at the back to show that it's a sphere. We have our North Pole, South Pole. That helps us to connect our longitudes. So, okay, this is not great. Let me draw again. All right, so this is our 20 degrees west, and this is 0, longitude 0 degrees. And we have our A here, we have B here, and we have C here. Now the question is, we should find to one decimal place the shortest distance from A to B. Now remember we said that this latitude is actually a plane, just as the equator is also a plane. And so it's a plane cutting the earth, and when it does that, it gives a circle. So the latitude can actually be represented as a circle which has a center. So if we have point A here and point B here, if we connect the center to A and B, we're going to have a certain angle here. And that angle is the angle between this longitude, 20 degrees west, and this longitude, which is 0 degrees. So we can draw a picture. If we draw this picture here, we have the center of the latitude, that is D. We have point A here, and we have point B here. And we are saying that this angle is the angle between the two longitudes. So it's 20 degrees. 20 degrees because this one is 0 degrees and this is 20 degrees west. And that is the angle between those two things. All right. So if we could find the length of this arc, the arc from A to B, that is the shortest distance from A to B. How do we find the arc? Well, this is a radius, little r. This is different from the radius of the Earth. This is like the radius at the latitude, this radius, which is different from this radius, which is from the center of the Earth to where the equator and the longitude 0 degrees intersect. So it's a different radius, and we have to find a way to calculate it. And one way to do it is to use the idea that we found. If we connect this center O to the line to the point B, then we already said that this angle is K degrees because the latitude is K degrees south. This angle is K degrees. We already found K to be 8, but for now I just put K here. And when we do that, now we can draw a picture like this. We have this, and we have this, and we have that. So we have the center of the Earth here. We have this point, let's call it point E here. And then we have point B here. And then we have, let me call this point D. We have this point D. So what do? We said this angle is K. And if this angle is K, these two lines are parallel. Therefore, this angle is also K. And we already found K to be 8 degrees. So let me just change this K and that K. Let me just write 8 degrees directly. So we have 8 degrees, another 8 degrees here. And then if we connect O and D, we have a right angle triangle here. Now the radius we are looking for, R, is right here. And then this line, the hypotenuse of the right angle triangle, is big R, which is the radius of the Earth. So using SOHCAHTOA, we can write that the cosine of 8 degrees is equal to adjacent, which is R over hypotenuse, which is big R. Now, because we know big R, or let me just write in another way. So now little r equals big R times the cosine of 8 degrees. Because we know big R is 6,400, we have 6,400 cosine of 8 degrees. So little r, if we punch into our calculator, this 6,400 times cos 8 degrees, what are we going to get? We are going to get this number, 6,337.7156. This is to 4 dp. All right, so now we found the radius of this circle, which we're trying to use, the circle. All right, so we know that the shortest distance from A to B is an arc on that circle. And what is the length of that arc? The length of the arc is, because the arc subtends an angle of 20 degrees at the center, we have 20 over 360 times 2 pi r. Now this r is the radius of the latitude, which we just calculated as this. So we can substitute these values into it. When we do that, we get, well, we can immediately cancel this. 20 divides itself 1 and divides 360 18. So we can write this as 1 over 18 times 2 times pi, which is 22 over 7, times r, which is this long number. Let me just write it. So 6,337.7156. All right, so when we punch this into a calculator, we are going to get the length of the arc that we are looking for. And when we do that, the answer we get is 2,213.1705. But then we are asked to find to 1 decimal place. So we just need to write this number to 1 decimal place is 2213.2 kilometers. All right. So the next question is BIII. We are supposed to find to the nearest hour the time taken for an aeroplane to fly from B to C at 800 kilometers per hour. Now, we were given that the shortest distance between B and C is this 2,560. So now, if you have an aeroplane traveling at 800 kilometers per hour, then the time that that airplane is going to use to travel is this 2,560 over the speed, which is 800 kilometers per hour. So we can cancel the zeros. And then here we can choose to divide by 8, even though we can divide by a different number. If we divide this number by 8, this 80, we get 10. And then if we try to divide 256 by 8, what do we get? 8 divides 25, 3, and then remainder 1, 16, 2. So we have 32 over 10, which is equal to 3.2. So if we round this up to the nearest hour, it's going to be 3. So the answer is 3 hours. Question 9. On a certain day, 2 shows of a movie premiere was aired. The cost of tickets for the first show was X cedis each, and the total receipts from the tickets was 45,000 cedis. In the second show, the price of each ticket was reduced by 5 cedis, resulting in 300 more tickets being sold. This increased the total receipts by 9,000 cedis. Find the A, price of a ticket for the first show, and B, number of tickets sold in the first show. All right, so we have a bunch of information that we have to try to make sense of. We are told that the price of a ticket, so let's have price. We can try to represent the information in a table. So let's say we have first show here. Then we have the second show, the information on the second show here. So the price of a ticket in the first show was X CDs. So let me call that GHCX. And it says that the total receipts was 45,000. So let me say receipts. I just removed the total, but it's implied. So we got a total of 45,000 GHC, 45,000. And then in the second show, the price of each ticket was reduced by 5 cedis. So in the second show, the price was reduced. So if in the first show it was X, then in the second show it's X minus 5. And then this resulted in 300 more tickets being sold. So we can also have a row for the number of tickets. Let me call it NO tickets. So this tells us how many tickets. So however many tickets were sold here, we are told that the number of tickets sold increased. It's whatever whatever was here, it increased by 300. All right. And this increased total receipts by 9,000. Now, because the receipts over here we are given is 45,000, we add 9,000 to it. 45 plus 9,000, and that's 54,000. All right. So this is the information that we've been given in the problem, and we want to try to use this to solve it. Now, the first thing, or one of the things we can do, is to find this number of tickets. I mean, just write an expression for it. So let's do that. If the price of each ticket is X, right, and the total receipts was 45,000, then the number of tickets sold is just the quotient. We divide this 45,000 divided by X. All right. Now, in the second show, if the number of tickets went up, then again, it's just this quantity, this 45,000 over X plus 300. So we write that 45,000 over X plus 300. All right. So now what can we use this information for? One thing we can do is that we have, if we look at this second column, we have one way of representing the number of tickets sold. So this is one expression for the number of tickets sold, but we can find another expression for the number of tickets sold. You remember that over here we divided this 45,000 by X, and that's how we got the number of tickets sold. So over here too, we can divide this 54,000 by this quantity X minus 5, and then we'll get another expression. So we have that 54,000 over X minus 5. That's another expression. Call it expression 2. So this expression 2 and expression 1 must be equal because they represent the same thing. So if we set them equal to each other, we have 45,000 over X. Then we add 300 to that. These two expressions are equal to each other. So we can use that information to solve for X. So what do? Well, there are a number of ways of thinking about this. One of them is we can divide both sides by 300 to simplify. This is a multiple of 300. 45,000 is a multiple of 300, and 54,000 is also multiple of 300. We don't want to deal with huge figures, so we just divide everything by 300. When we do that, what do we get? Over here, we get 180 over x minus 5. And then over here, what do we get? We get 150 over x. And over here, what do we get? We get 1. All right. So then what do? We can multiply both sides by the products of the denominators. So this x minus 5 and this x, we can multiply both sides by that. And when we do that, so let me just write that. Multiply both sides, bs, by x times x minus 5. Now when you multiply this by that, you get 180x here. And then here you get 150 times x minus 5. Then you get x times x minus 5. That's what you get when you multiply that quantity by 1. So we expand. We get 180x. Then we get 150x. Then minus 5 times 150. That's 750. Then x times, we expand this bracket, we get x squared minus 5x. Okay, so we can try to group like terms, or we can try to bring everything to one side because it's becoming clear that we are getting a quadratic. So if we bring everything to one side, we are going to get x squared. X squared. Then we have minus 5x here. We have plus 150x. Then we have minus 180x because we are going to bring that to the other side. So we have 150x minus 180x, which is minus 30x. Then we subtract 5x. That becomes minus 35x. And then we have minus 750. And that is equal to 0. So we have to factorize this quadratic. Let's try to create space. I don't want to erase, so let me erase what we have at the top, this thing. All right, so we're trying to economize on the space that we have. Now we're trying to factorize this quadratic. And how do we do that? We want to find two numbers that we multiply to get 750, and then, or minus 750, and then when we add them, we get minus 35. Which numbers can we do? We can do 50 and 15. So 50 times 15 is 750. So we can do minus 50, so x minus 50, and x plus 15. So when you expand this, you're going to get this expression. You can, if you're not sure, you can expand it just to convince yourself. Now, when this is the case, we have that x is going to be equal to 50, or x is going to be equal to minus 15. Now, because we are dealing with tickets here, which cannot be negative, the answer is that x is equal to 50. That means that the price of a ticket for the first show is 50 cedis. All right. Then we're also being asked, that's 9b, the number of tickets sold in the first show. We already found that the number of tickets is 45,000 over x. So we can try to divide 45,000 by this quantity that we found. So 45,000 over our x is 50. So what is 45,000 over 50? Is 4,500 over 5. That is 900. So the number of tickets sold in the first show must be 900. Question 10. A line cuts the y-axis at 0 minus 3 and the x-axis at 3, 0. Write in the form y equals mx plus c the equation of the line. So we have a line. We can draw our axes. So we have on the x-axis we are cutting at 3, 0. And then on the y-axis we are cutting at minus 3. So the line is like this. All right. And so when we write the equation of a line in this form, y equals mx plus c, m is the gradient. So we can try to find the gradient. The gradient of this line is, we can do it from this diagram, is the change in y over change in x. And the change in y from here is 3. And the change in x is also 3. So the gradient of the line is actually equal to, let me write 3 over 3, which is equal to 1. Of course, we can use the gradient formula. If you write m for gradient and you say it's y2 minus y1 over x2 minus x1, you can substitute the values of x and y into it to be sure that the gradient is indeed 1. But this picture should convince you, that the gradient of the line is 1 because the x-intercept is 3, y-intercept is minus 3. And if you draw this triangle, which represents the gradient, the length of this side will be 3. The length of this side will be 3. So the ratio is 1. So if you know the gradient of the line is 1, and you know the y-intercept is minus 3, then you can simply write the equation of the line as y equals x minus 3. So that requires you knowing about how the equation of a line is represented. But once you know that, then this becomes as simple as that. But if you don't know this, then you can use other methods where, for instance, if you know how to find the equation of a line when you have the gradient and a point on a line, you can try to use that method. And there are other methods as well. As usual, you can download a full set of questions and solutions from preppyonline.org, and you will see different ways of doing this problem. So 10b, we have two spheres that have their surface areas in the ratio 16:25. And the volume of the smaller sphere is 48 cubic centimeters. Now we're supposed to find the volume of the bigger sphere as well as the radius of the bigger sphere. So here what we need to know is that if you have the surface areas of a sphere or two spheres in the ratio 16:5, so if you have this, 16:25, if you have surface areas in this ratio, then the radii, let me call that, the radii are automatically going to be in a certain ratio as well. So you have, call this surface. So surface areas are in this ratio. Then the radii, or the radii is the plural of radius. So their radii are going to be in the ratio square root of 16 is to square root of 25. And this is equal to 4:5. And also their volumes are going to be in the ratio 4 cubed is to 5 cubed. Now, these are all properties of plane figures, or not just plane figures, any objects that are similar. So if you have plane figures that are similar, their areas are going to be in a ratio that is equal to the squares of the lengths of the respective or the let me call the length of the respective figures. So for instance, if you have a square like this and another square like this, and you say that their areas are in a certain ratio, let's say you say their areas are in the ratio 1 is to 9, you are automatically saying that their lengths, the lengths of their sides, let me draw. So let's, the square has all its side lengths equal. So you are saying that the length of this side to the length of this side is in the ratio square root of 1 is to square root of 9. So that's the idea that we are using. And if you had cubes, you'll be dealing with um, similar ratios between their volumes as well, where you have to cube the ratio of the lengths to get the ratios of the volumes. All right, so if the areas are in this ratio, then the radii are in this ratio and the volumes are in this ratio. Now, if the volumes are in this ratio and the volume of the smaller sphere is 48 cubic centimeters, then what is the volume of the bigger sphere? So the volumes are in this ratio, and the smaller one is 48. So the question is, what is the bigger one? We can cross multiply. So this is a direct proportion. So we have that 4 cubed over 5 cubed is equal to 48 over x, where x is the volume of the bigger cube. So when you cross multiply, you will get 4 cubed times x is equal to 48 times 5 cubed. Or let me just write that in brackets. All right, so x is now 48 times 5 cubed over 4 cubed. And we can punch that into our calculator. When we do that, we are going to get the volume of the bigger cube as 93.75 cubic centimeters. So that's what you get when you punch this into your calculator. Let me write x. X is equal to what? 48 times 5 cubed, which is 125, divided by 4 cubed. When you punch this into your calculator, you should get this quantity. Now, if we have the volume of the bigger sphere, then we can use that to find the radius of the bigger sphere. So let me create some space here. Let me clean this up. So clean. All right. So if we have this 93.75 cm cubed as the volume of the bigger sphere, then we equate that to the formula for the volume of a sphere. Now, the formula for the volume of a sphere is 4/3 pi r cubed. All right, so if we take pi to be 22/7, then we have 93.75 is equal to 4/3 times 22/7 times r cubed. So r cubed is going to be what we get when we just multiply both sides by the reciprocal of that. So you can punch that into your calculator. When you do that, you're going to get r cubed is equal to this fraction 7875 over 352. And so you take the cube root of that. R is going to be this cube root of 7875 over 352. And that is equal to 2.818 centimeters to 3 decimal places. So if you round it up to 3 decimal places, that's where you're going to get for the radius of the bigger sphere. Question 11. Denchemchrome is 35 kilometers from Pseudochrome on a bearing of 050 degrees. Chichichrome is 12 kilometers from Pseudochrome on a bearing of 140 degrees. Illustrate the information in a diagram, and then find the distance between denchemchrome and chichichrome, and then the bearing of Pseudochrome from chichichrome. So we can draw this information. Let me first. So the bearing, we have denchemchrome is 35 kilometers from Pseudochrome. So if you have Pseudochrome here, so let's write S for Pseudochrome here. Then we are saying that if you have a bearing, if you're on a bearing of 50 degrees, now bearings are measured from due north. So if you go some 050 is 50 degrees. So if this angle is 50 degrees, then denchemchrome is somewhere on this line. So we can put it here. And this distance is 35 kilometers. Let me write that. All right. And then we have chichichrome is 12 kilometers from Pseudochrome on a bearing of 140 degrees. So again, if we measure 140 degrees, that's going to be somewhere here, let's say. So if you make this angle 140 degrees, 140 degrees, this one was like this, then Pseudochrome, chichichrome is somewhere here. Let's write K for that. And we are told that that is 12 km. All right. And we are supposed to illustrate the information in a diagram. So we can draw a diagram like this. If you write that this is due north, so you are due north and you measure 50 degrees clockwise and you move 35 kilometers away, you get denchemchrome. And when you measure 140 degrees clockwise and you move 12 kilometers away, you find chichichrome. So we can draw that diagram. All right. Now we're asked to find the distance between denchemchrome and chichichrome. So that's this one. Let me draw this here. I'm trying to find this distance. Well, so one idea we can use is that this angle is a right angle. Why is it a right angle? Because this full angle is 140 degrees and this angle is 50 degrees. So the remainder, if you subtract this 50 from 140, that leaves only 90 for this side. So we have a right angle triangle in which one side is 35, the other side is 12, and we are asked to find the hypotenuse of that triangle. So we use Pythagoras theorem. Pythagoras theorem says that the length of the hypotenuse, let me write that, dk, so the length of that squared is equal to 12 squared plus 35 squared. All right, so we can punch these things into our calculator to see what we get. 12 squared is 144. And what is 35 squared? 35 squared is 1225. So when we add the two together, we're going to get a number, 1369. So now dk, which is what we're looking for, is going to be the square root of 1369. And that square root is 37. So the distance from denchemchrome, or between denchemchrome and chichichrome, is 37 kilometers. We are also being asked to find the bearing of Pseudochrome from chichichrome. That means that you stand at chichichrome here and then you try to find the bearing of Sadochrome, which is here. Now we draw another line due north, so this is north, and so what we are trying to find is this angle. That's going to give us that bearing. And we have a number of ways of thinking about that. The first is that since we already know the bearing of Chechachrome from Sadochrome, that's this 140 degrees. If we notice that this line pointing due north, these two lines pointing due north are parallel, then this angle, let me call this angle here, this angle and the 140-degree angle are corresponding angles. Therefore, they add up to 180 degrees. That means that this angle is 40 degrees because 40 plus 140 is 180. And then this bearing that we are trying to find is basically just the angle around a point minus this 40 degrees. So the bearing we are looking for must be 360 degrees minus 40 degrees, which is 320 degrees. Of course, we can always use the formula that says that if you want to find the bearing, the back bearing, if the given bearing is less than 180, you add 180 to it. So in this case, that we have the bearing from Sadochrome, Chechachrome, the bearing of Chechachrome from Sadochrome being 140 degrees. Because that bearing is less than 180, to find the back bearing, we can add 180 to it. So 140 plus 180, what does that give us? It gives us 320. So the same 320 we got here, using the reasoning we used, is what we get by using the formula. All right, so 11b, we are asked to solve this equation. So how do we proceed? We can multiply through by the product of the denominators. We can also try to simplify the left-hand side and write it as a single fraction. So let's do that. Let's write the left-hand side as a single fraction. So we write it over a common denominator. We have x plus 1. Then we have 3x minus 1. Then we try to write this. So this fraction, x over x plus 1, the x plus 1 will divide. The denominator will be left with 3x minus 1. So we have this. And then we have minus x plus 1 times another x plus 1. So we have this. Let me clean this up before we get confused. All right. So we have this that we are trying to simplify. So when we do so, what do we get? We try to simplify the numerator. We get 3x squared minus x. And then over here we get this one. It's a perfect square, so we have x squared plus 2x plus 1. And then we divide by the product. We can expand the product because eventually we're going to multiply things out. So let's write that. We get 3x squared minus x plus 3x. So that gives us plus 2x and then minus 1. And then we continue our simplification. So this quantity is what we are bringing up here. We have 3x squared minus x. Then we have another minus x squared. So 3x squared minus x squared is going to be 2x squared. Then let's look at the terms in x. We have minus x minus 2x. So that gives us minus 3x. Then we have minus 1. And then we have this denominator, which is 3x squared plus 2x minus 1. All right, so this expression is equal to 1 over 4. So we can just cross multiply. So we have 4 times this 1 here, and then 1 times the 1 at the bottom. So we have 4 times 2x squared minus 3x minus 1 is equal to, let me clean what we have on the right. All right, so what is it equal to? It's equal to 3x squared plus 2x minus 1. So we expand, we get 8x squared minus 12x minus 4 is equal to 3x squared plus 2x minus 1. All right, so we try to group like terms. Let's bring all the x squareds together. We get 5x squared. Let's bring all the x's together. We get minus 14x. And then let's bring the constant terms also together. We get minus 3. So now this is equal to 0. So we can try to factorize this. There's always a trick you can use when you have a quadratic like this. If you don't know the trick, you can learn about it in another video, in which we'll explain the trick. But basically, you try to break the coefficient of x squared into its factors, and then the constant terms as well, and then you try to find a way to multiply them together to give you the sum in the middle. So here it's looking like this is one way to do it, that if we multiply 5 by minus 3, we get minus 15. Then 1 by 1 is 1. So when we add, we get minus 14. So when we are writing the factors, we change the order. Even though here 5 was going with minus 3, here 5 is going to go with 1. And then that's 5x. And then here x is going to go with minus 3. So this is the way in which we factorize it. And when we do that, we can now solve for x. X is going to be equal to minus 1 over 5, or x is going to be equal to 3. So those are the two values we get for x. It's always good to cross-check your work by substituting the values back into the equation. So you can do that to confirm that everything we've done is correct. Question 12. The ages in years of 6 students arranged in order of magnitude are, we have this 2x plus 1, we have 4x minus 1, 5x, m, n, and r. If their ages form an arithmetic progression, calculate the ages of the students. That's 1. And then 2, the standard deviation of the ages. All right. So we have how many ages? 6 ages. And we are told that they are in arithmetic progression, or they form an arithmetic progression. The important idea about arithmetic progressions is that when you have, let's call the terms U1, so the first term, the second term is U2, the third term is U3. The idea in an arithmetic progression is that you always add the same thing. So if you have U4, the way you move from U1 to U2 is you add something, let's call it D. That's called a common difference. You add the same thing. If you have U2 and you want to go to U3, add D to it. If you have U3, you want to go to U4, you add D to it. So you always add D, the same number you keep adding to get the next term. That also means that if you were to find the difference between the terms, so if you find the difference in U2 and U1 is the same as the difference between U3 and U2, and is the same as the difference between U4 and U3. So in our case, what this means is that if we take the first and the second terms, let's try to find the difference between them. So the second term is 4x minus 1. If you subtract the first term from it, which is 2x plus 1, this quantity is equal to taking the third term, which is 5x, and subtracting the second term from it, 4x minus 1. So if we immediately have this condition or this expression, and from this we can solve for x. So let's do that. On the left hand side we have 4x, this 4x minus this 2x, that gives us 2x, and then we have this minus 1, and then we have another minus 1 because of the negative here, so that gives us minus 2. Then over here we have 5x minus 4x, which is x, and then we have minus 1, so we have plus 1. All right, so we simplify further. We're going to get x is equal to 3. All right, so if x is equal to 3, what does that mean? If x is equal to 3, let me write that. If x equals 3, then what is 2x plus 1? 2x plus 1 is equal to 7. What about 4x minus 1? 4x minus 1 is 11. What about 5x? 5x equals 15. So already we have the first 3 terms of our sequence. The first is 7. Then the next is 11. That's what we found here, 7, 11. And then the next is 15. So just observe, to move from 7 to 11, what do? You add 4. To move from 11 to 15, what do? You add 4. And so we can expect, because it's an arithmetic progression, the next term is what we'll get by adding a 4 to 15. So the next term is 19. And then after that, the next term is 23. After that, the next term is 27, and so on. We have 6 ages, so these are the 6 of them. That means that this M, N, and R are actually this. Let me use a different color. So we have M, N, and R. So M is 19, N is 23, and R is 27. Anyway, so these are the ages of the students. These 6 numbers, these are the ages of the students. All right, now we are being asked to find the standard deviation. All right, so it's always convenient to draw a table. You have the ages, 7, 11, 15, 19, 23, 27. Then we need to find the mean of the ages. That's an interesting one. Here there is a nice idea that we can use, because these are numbers which are, if you like, separated by the same amount each time. The mean is going to be, if you like, the midpoint of these two numbers. So the mean is going to be 15 plus 19 over 2, which is equal to 17. But we will not use that idea. we will find the mean using the usual method. So we'll add the numbers. We can add the numbers, and then we divide by the sum we divide by how many there are. There are 6 of them. So we can add this to this to this to this to this to this. You can do it on your calculator. If you also know how to find the sum of an arithmetic progression, you can use that. In this case, the sum in an arithmetic progression, you can always pair the numbers. So you can add this to this, 7 plus 27. What does that give us? It gives us 34. That means that this 11 plus 23 will also give us 34. And this 15 plus 19 will also give us 34. So the sum is going to be equal to 3 times 34. And because there are 6 of them, we divide by 6. So 3 divides 3, 1 divides 6, 2. 2 divides 1 divides 34, 17. So the mean is, again, going to be 17. Again, if you don't know this idea, no problem. You can simply punch these numbers into your calculator and find the sum, and then divide by how many there are. There are 6 of them. So that's the number that you are going to divide by. But the important thing we needed was the mean, because here we want to write x minus the mean, which is x bar. So here we find 7 minus 17 is minus 10. 11 minus 17 is minus 6. 15 minus 17 minus 2. 19 minus 17 is 2. 23 minus 17 is 6. And 27 minus 17 is 10. Then we find the squares of these deviations from the mean. So we square these quantities. When we do, what do we get? Minus 10 squared is 100. Minus 6 squared is 36. Minus 2 squared is 4. 2 squared is 4. 36. 100. All right. So here we can find the sums of these numbers. We can find their sum. And if we see that there is symmetry, that means that going up, we have the same numbers as going down. Then we can just add this to this to this and multiply the answer by 2. So here we get 140 times 2. That's equal to 280. So that's the sum of the numbers in this column. And so you divide that 280 by 6, and that's going to give you the variance. So the variance is going to be 280 over 6. And to find the standard deviation, you find the square root of this variance. So you can punch this into your calculator. 280 over 6, you punch it into your calculator, and then you take the square root of that. That's going to give you the standard deviation. So you're going to get 6.83 when you punch this into your calculator to 2dp. Now, standard deviation, the unit of standard deviations in this case is years. Standard deviation always has the same units as the quantity whose standard deviation you're finding. So here, the quantities we are dealing with are ages in years. So the unit of standard deviation is going to be years. Question 13. So this is the last question on the paper, and it's a question on construction. And we are trying to, we've already provided the solution because it's not easy for us to demonstrate the construction right here. So we'll just walk through what we did, and then you can try to do it on your own. So using a ruler and a pair of compasses only, we are supposed to construct triangle ABC, all right, such that AB is 8 centimeters, BAC is 45 degrees, and ABC is 67.5 degrees. And we are supposed to locate the point O inside triangle ABC that is equidistant from A, B, and C. And then we are supposed to construct a circle with center O, which passes through A. And then we are supposed to measure OA. All right, so using a ruler and a pair of compasses only, you want to construct triangle ABC with AB equal to 8 centimeters. So this is A, this is B. We want this AB to be 8 centimeters. What we do is that we can draw a straight line like that, and then we mark this point. You call it A, then you open your compass and then draw an arc. So when you open your compass, you open it to 8 centimeters, you draw an arc with that 8 centimeters, and that's where your B is going to be. So that's how we obtain B. We first mark our A, and then we stand at A, we open the compass on the rule, we measure 8 centimeters, and then we draw an arc, and that is where B is going to be. All right, then we want to draw an angle BAC as 45 degrees. So we have B here, A, that means C. You know, now we've completed the diagram, so we know exactly where C is. But if you don't know, you just have an idea that this is B, this is A, so C is somewhere here. But you have to construct it so that this angle is 45 degrees. So what you do is you can stand at A and you draw a perpendicular. So you draw that, then you stand here, you draw an arc, you stand here, draw another arc, and then you draw a line through A and the intersection of those arcs. That's going to give you 90 degrees here. And then you bisect that 90-degree angle to get this line. So to bisect the 90-degree angle, you can draw an arc here. We already have that arc. Then you draw another arc here. Now the compass should be open to the same distance for both arcs. And then now you stand here, you draw an arc, you stand here, draw another arc, and then you draw a line through A and the intersection of the arcs. That gives you the 45-degree angle. We also want ABC to be 67.5 degrees. So where is that? This is A, B, C. So we want some angle here that is 67.5 degrees. The way to do that is to first, one way to do it is to draw a perpendicular here and then bisect that perpendicular just like we did, and then bisect the angle between the 45-degree angle and the 90-degree angle. The reason is that this 67.5 is equal to 45 plus 22.5. Now 45 is what you get when you bisect a 90-degree angle. So we drew this 90-degree angle here, then we bisected it. So this is 45. Then we now bisect this angle between the 45 and the 90 degrees. That's how come we get an extra 22.5 to add to the 45 to get the 67.5. So when you do that, now you have your line from A going through C, you have a line from B going through C. The intersection of those lines is your point C. Then we are told to locate the point O inside triangle ABC that is equidistant from all the 3 points A, B, and C. The idea here is that if we know that the locus of points that are equidistant from the two ends of a line segment or 2 points is the perpendicular bisector of the line segment. So if you're told that give us all the points that are the same distance from A and B, really what you're being asked to do is to bisect the line segment between A and B. The line segment between A and B is the locus of points equidistant from A and B. So every point on this line, since it's the bisector, is the same distance from both A and B. And how do we construct the perpendicular bisector? You stand at A and you open your compass to a reasonable radius. It just has to be longer than half of the length of the line segment you're trying to bisect. So you stand here, you draw one up, one down. You stand on the other side, you draw one up, one down, and then you draw a line between the intersection of the arcs. All right, so we also bisect line AC. Same idea. We want to get all the points that are the same distance from both A and C. So now, if you manage to get all the points that are equidistant from A and B, as well as all the points that are equidistant from A and C, then what is the intersection of those two lines going to be? The intersection of the two lines will be such that that intersection must be equidistant from all the 3 points A, B, and C. The reason is that every point on this line is equidistant from A and B, and every point on this line is equidistant from A and C. So if these two lines are meeting at a point, then that point must be equidistant from A and B. It must also be equidistant from A and C. That means it's equidistant from A, B, and C. And that is what question II is asking us to do. So we find the point O, and then III is saying that we should stand at O and draw a circle which passes through A. So you stand, you put your compass pin at O, you open to A, and then with that radius, you draw a circle. That's what the circle is. Now, what you'll discover is that that circle, if you drew things correctly, will pass through A, it will pass through B, that's here, and it will pass through C. That's why our circle is passing through all the 3 points, A, B, and C. And this is a special circle. It's called a circumcircle. Circumcircle. It's a circle that passes through all the vertices of the triangle. And this center that enables us to draw the circumcircle is called the circumcenter. All right, so the last question, which is 13b, says that we should measure this distance OA. So you just put your rule on one of the points and then see where the other point falls. And when you do that, you'll find that OA, let me write it this way. So OA is about 4.3 centimeters. You'll find that that is, let me write that more permanently. OA is about 4.3 centimeters. I mean, if you get 4.4, 4.2, it doesn't matter so much. There's always issues with construction equipment, compasses, and so on. But this is the exact answer. Not the exact answer. It's approximate. This is the approximate answer. If you're getting the answer to one decimal place, then that is it. So that brings us to the end of the series of videos where we solve the questions on the 2026 WASSCE Core Maths Paper 2. As usual, the full set of questions and solutions can be got from our website, preppyonline.org.